Welcome to this year's Jump into STEM student competition. My name is Mini Malhotra. I am a research staff member at the Oak Ridge National Laboratory. This pre-recorded presentation is meant to provide background and additional information for one of this year's 3 challenge topics. This topic, Sustainable and Resilient, relates to the impacts of climate change and solutions for the built environment for mitigating those impacts. Around the world, we are experiencing dramatic rise in the number and intensity of extreme weather events such as severe storms, hurricanes, freeze, floods, heat waves, droughts, wildfires, and so on. These events are not always singular or isolated. They can occur in complex combinations in rapid succession. These events become disasters when our lives and livelihoods, buildings, services, infrastructure, and natural resources get exposed to these events. This figure shows climate-related disasters in the US from 1980 to 2021, which had caused over $1 billion damage each. The last 2 years, 2020 and 2021, has seen record high number of disasters. These events damage the natural environment, the built environment and infrastructure that includes our homes, buildings, roads, utility services, and communication network, and pose threat to public health, safety, and well-being. They can impact our access to potable water, sanitation, food, energy, impact air quality, and may even result in loss of lives. Climate change and extreme weather cause persistent stress on the environment, society, and economy. They are long-term impacts of climate change with cascading and compounding consequences. For example, changing weather patterns, water shortages, decreased agricultural production, food shortages, they are all cascading effects of climate change. Another example, the rising global temperatures, increasing cooling loads in the buildings, which result in increased electricity demand and increased emissions, which in turn adds to the environmental degradation. The impact of extreme weather and persistent stress is disproportionately large on communities who are underserved, marginalized, and vulnerable, who lack the capacity to withstand and recover from these impacts. They experience barriers to social, economic, political, and environmental resources, such as housing, healthcare, emergency response, and so on, due to ethnic and racial discrimination, low socioeconomic status, disadvantaged background, or location in rural or impoverished urban areas, or even age, illness, or disability. To mitigate the impacts of climate change, we need buildings, communities, and infrastructure that are designed to be resilient and sustainable, which can respond better to both extreme events and persistent stresses. And we need to make sure that these design solutions reach the disadvantaged populations who suffer the most. Let us look at what it means by resilient and sustainable built environment. Resilience means the ability of a system to adapt to, persist during, and rapidly recover from a disruptive event. The system could be the ecosystem, society, economy, businesses, or the built environment. Strategies to improve resilience focus on disaster preparedness, mitigation, and recovery. A resilient built environment will have less damage, maintain critical operations during or after disaster, and return to normal operations quickly and effectively. Sustainability means meeting the needs of current generation without compromising the needs of future generation. The focus here is on improving quality of life through social well-being and economic growth, through practices that minimize damage to the environment. A sustainable built environment will meet our most basic needs of shelter, security, mobility, and communities, and at the same time consider the sustainability challenges of climate change, pollution, resource consumption, and land use. For example, by using low carbon, low impact, non-toxic materials, requiring less energy for operation, and considering reuse and recovery for the end of life. There are opportunities and challenges in integrating resilience and sustainability goals. In most cases, resilience and sustainability objectives complement and enhance each other. Systems that are more resilient can better achieve and maintain sustainable operation. Likewise, systems that are more sustainable lose less critical functionality and recover more quickly from extreme events. For example, buildings which are in compliance with building energy codes and standards can maintain sustainable temperatures for longer period of times. They require less energy, which allows alternative power sources during power outage to go further to sustain people who are sheltering in place or trying to perform critical job functions. More efficient heating and cooling equipment also mean less pressure on the power grid and more reliable grid infrastructure. In some cases, integrating resilience and sustainability could be challenging due to the fact that resilience is response to low probability, high impact events, whereas sustainability is response to high probability events with long-term impacts. For example, oversizing a system for extreme weather conditions may result in non-optimal system operation. Or resilience strategies focused on rapid recovery may not achieve long-term sustainability. Therefore, balanced solutions are needed to optimize both resilience and sustainability. As I had mentioned earlier, the impact of climate change is significantly large on disadvantaged populations. So the third key consideration for mitigating the impact of climate change is equity. This means accounting for the social distribution of the impacts of climate change, understanding how various populations and communities are affected, what type of barriers they face in the event of disaster, or for coping with the persistent stresses of climate change. Equity should not be afterthought or a box to check. In this challenge, we ask students to develop innovative technical solutions to improve the resilience and sustainability of the built environment, making sure that these solutions enable underserved communities to withstand and recover from extreme weather and persistent stress caused by climate change. You may consider this problem at an individual building scale, community, city, or regional scale for new construction, existing buildings, or communities and infrastructure. There are tools and frameworks which can help in methodically develop solutions and evaluate how well sustainability and resilience objectives are met. I encourage you to utilize them for developing your solutions. The following 2 slides contain links to additional resources for topics covered in this presentation. These are meant to provide you context and a starting point for your own investigation. You can also look at the challenge description where additional references are cited. We hope this presentation has been helpful at introducing this broad challenge topic and has generated interest in potential innovative solutions. Please refer to the JumpintoSTEM.org website for all challenge-related information. Thank you and good luck.